All right. So this is the 3.4 problems now. Basically, I'm going to go ahead and let you know that with the problems, when they say elimination or substitution, I don't care which method you use. Okay, the ones that they say substitution, it's probably easier to use that method. But it's up to you. I'm not going to be picky about it. You can choose whatever method you like. Eventually, I'm going to teach you how to do them on your calculator, but even when I do that, I'm still going to require you to know how to do them by hand, so, as well. So, the first set of problems, okay, it says to tell whether the given ordered triple is a solution of the system. So, what is an ordered triple? Okay, so we normally have an ordered pair. What is that? X and Y in parentheses, okay? An ordered triple is X, Y, and Z. Okay? This is actually more beneficial for you than stuff. This is a three-dimensional thing. Basically, we are like three-dimensional. So things like what we do in life is going to be more three-dimensional than two-dimensional. So this is actually more applicable. Just also slightly harder. So that's why we're spending 2 days on it, okay? So don't stress out about it if you're like, this isn't making sense. We're going to spend plenty of time on it. Okay, so we're going to start out with 4, -1, -2, and 5 is going to be the ordered triple, and the equations are 4x minus y plus 3z is equal to 13. X plus y plus z is equal to 2. And x plus 3y minus 2z is equal to -17. For these ones, no, but when we're actually solving them, yes. So these ones, we're just taking these numbers and plugging them in and seeing if they work. We ultimately are, but this starting out easy first. All right, so we're going to start out just by plugging them in, okay? I would say as a general rule, okay, as soon as you get one that doesn't work, you can say not a solution, okay, because it has to be a solution to all of them. But if you get that like 2 of them are, you probably can assume that they all are going to be, okay? But we do have to check more than one if we get a yes on the first one. So basically I'm just plugging in these numbers. So this is X, Y, and Z. So those are going in. So I'm going to have 4 times -1 minus -2 plus 3 times 5 is equal to 13. So I have -4 minus a -2, so that's -4 plus 2, which is -2. Okay, so that comes out to be 13 is equal to 13, so that one works. Okay, but just because one works doesn't mean they're all going to work, so I need to try another one. Let's go with the middle one. So -1 minus 2 plus 5 is equal to 2. Is that true? Okay, 2 is equal to 2. So I need to see at least 2 of them, okay? And it should work. Okay, if it works for 2 of them, it should work for all 3 of them. But let's see. Not these ones. Well, yes, this section, but not this particular one. All right, let's do number 6. That's it. You're just showing that it's a solution. If it's not a solution, you would just write not a solution. In general, yes, that should be fine. All right, so this one we have the point -5, 1, 0. Then we have the equations 3x plus 4y minus 2z is equal to -11. 2x plus y minus z is equal to 11. X plus 4y plus 3z is equal to negative 1. Alright, I want you guys to plug those in and see what happens with this one. I think you all should be capable of plugging them in. Yeah, that's next. This is just the first thing of just how to check your solution, basically. It just depends. I mean, you kind of do both within the problem. So I usually end up starting with elimination, but I always end with substitution. So. Yep. Then it's automatically no solution, as soon as it's not true for one of them. Huh? You don't have to use graph paper. You can just do it on there. Sorry, I forgot to tell you that. I thought I had taken that out of the instructions and I didn't. I mean, just to be safe, I mean, it's not like they're hard. You could go ahead and check all of them. Yeah. I mean, this is just basically making sure you know how to check them, because sometimes I will say you need to check your solution. And so I usually just check it in one when I check my solution. And if it works, it works. And I trust that it's right. It means no solution. Are they okay? Alright, so did we get a solution or no? No, why not? Second one was not equal to 11. Okay. So not a solution. Alright. Let's get into some harder stuff now. Well, the good news is it probably won't show up on your test, so. Easy problem. On a scale of 1 to 10, how hard is this stuff? Hard? Not hard, but tedious? Yes, very tedious. If you mess up in step 1, I'm not going to penalize you as bad if you use the, okay, so this is a good question. If you get the wrong number in step 1, and you use that wrong number all the way through and end up with the wrong answer, but you did the process correctly, I will not take off nearly as many points. Okay, if it's because you messed up on something early in step 1 and it threw you off for the rest of it, I'm pretty nice with these ones because I know they're harder and I know there's a lot of steps and things I have to play into it. So, if you mess up in step 1, don't stress out that you're going to get 8 out of 10 points off because, oh, I messed up in step 1. I'm probably only going to take 4 or 5 points off instead, so half, instead of the whole thing. If you show your work and it makes sense, that's fine. There has to be work shown for me to do that, though. Okay. All right. Starting with elimination. 2x minus y plus 2z is equal to negative 7. Negative x plus 2y minus 4z is equal to 5. X plus 4y minus 6z is equal to negative 1. We're going to find x, y, and z.
Is this the one where you added like the
So basically, I want to pick two of the equations and rewrite them to get it down to something in two variables. So I want to find two that would be easy to cancel something out. So by looking at this, I would say I can use these bottom two. I think somebody just said that. Because they're already opposite. Okay? So I would get down here. I'm not going to actually rewrite them. I'm just going to, normally I would, but. So I end up with 6y minus 10z is equal to 4. 5 minus 1. These are these two. Those two combined give me this. Okay, but I need two equations and two unknowns, so what else do I need to do? Two unknowns are your variables. Top one and the middle one, okay? So I need to multiply this one by 2. Okay, I'm going to do this over here. Okay, so I need to multiply this one right here by 2 so I can cancel that stuff out because I need to cancel the same variable, okay? If I don't cancel the same variable, it does not work. Okay, it's not going to help you. It's going to make your life harder. So 2x minus y plus 2z is equal to negative 7. Now I'm multiplying this second equation by 2. Negative 2x, let's see, plus 2y minus 8z is equal to 10. Yep, thank you. I was looking at the wrong one. It's equal to 10. So now combining stuff, I end up with 3y minus 6z is equal to 3. Now I have two equations with two unknowns, okay, so two variables I can solve for. So now I could use elimination or substitution. I'm going to use elimination because I think it's preferred. So I'm going to rewrite these. Let's see, 3y minus 6z is equal to 3. So I'm writing those now together, okay? But I need to get these such that I can cancel something out, okay? I need to solve for one of the variables now. So what should I do to do that? Multiply the bottom one by negative 2. Okay, so I'm going to copy down the top one. 6y minus 10z is equal to 4. Negative 2 times 3y is... Okay, negative 6y plus 12z is equal to negative 6. Now I can get this to be 2z is equal to negative 2, z is equals negative 1. Okay, so I'm going to circle this so I don't forget where it is. Okay. Now I'm going to take this and I'm going to plug it into one of these two equations. Okay, I want to solve for my other variable now. Huh? Yes, because I still need to solve for another variable.
I have a question. So, do you plug it into the one that you have not multiplied by yet?
I would plug it into one of these two original. It technically doesn't matter, but it would have to be into one of these over here. because there's two variables and I need to solve for the other one. So basically, once you get to this step, you're back to the easy stuff that you did last section. Or 2 sections ago. Okay, so now I'm plugging this in. Which one do y'all want to do, top or bottom? Top. Top? I don't care. Okay. 3y minus 6 times negative 1. Okay, it really doesn't matter. Is equal to 3. 3y plus 6 is equal to 3. 3y is equal to negative 3. Y is equal to negative 1. We're not done yet. Okay, I now have z and y. So now, no. I need to still get x. So I can plug it into any of these ones up here. Which one do you want? The middle one? How about something where x is already by itself? Yeah, the bottom one. Okay, the bottom one is more logical because I don't have to do any dividing or anything. Okay, so x plus 4 times negative 1 minus 6 times negative 1 is equal to negative 1. So this is x, let's see, negative 4 plus 6 is plus 2 is equal to negative 1. So x is equal to negative 3. Okay, so those are the 3 pieces. Now I need to write my ordered triple as x, y, z. Okay, your answer is not complete and correct until you have it written as an ordered triple. So negative 3, negative 1, negative 1, and that is the solution. Okay, and then you could go back to the stuff we did in problems 4 and 6, plug this into 1, and check and make sure it works. Okay, I'm not requiring you to do that right now, but just know that you could do that. I may let you do that on the test for extra credit, so just make sure you understand how to do that. Okay? You might be able to like take this and plug it back in like we did in 4 through 6 to verify that it's true. Like how I did on the quiz yesterday, like if you check it, extra point, that kind of thing. Are you already ready to do one by yourself?
Let's go. Do it, let's just try it. I'm really not ready. Can we just try it?
Okay, hold on, before we do that, my question is, can I only ever have one solution? I can have infinitely many solutions. I can have no solution. Okay?
Please give us one that's not complicated.
To try right now?
Yeah. Let's try ourselves. Just like number 10, like 12. 12 or something. What is 12 the hard one? 12 or 14? It's easy.
Alright, hold on. Let me focus this in and decide which one. As I said, these are literally going to take like whole pages to do them. Okay, probably like 5.
Can we do one together again?
Yes, we'll do one more together and then we'll do one that is you get to try. Okay, because we have today and tomorrow. Okay? That's what, yeah, you're not having any tonight. There's nothing today, there's nothing tonight. This is all going to be in-class problems today. Like that we're doing together or that y'all are working and then we check them together.
Give me one now, it will not.
Okay? 12. 4x minus y plus 2z is equal to negative 18. Negative x plus 2y plus z is equal to 11. 3x plus 3y minus 4z is equal to 44. Okay, so what's our first step? Let's see if y'all can walk me through it. So tell me what 2 equations you want and what I need to do to them.
And then multiply by 2.
First one and second one and multiply by 2?
Yes.
Okay. Multiplying the top one by 2, right? Okay. So, 8x minus 2y plus 4z is equal to negative 36. Yeah, 36. And then I just copy down the second one. Negative x plus 2y plus z is equal to 11. Usually the book is pretty nice and it won't make you multiply them both, but on occasion you might have to multiply them both to get something to cancel, so just make sure you pay attention to that. The second one I just copied down, the first one was multiplied by 2. So, now I need to combine stuff, so what do I get here? 7, oh, that's a z, hello, 7x. Okay, 7x plus 5z is equal to negative 25. Now what do I need to do? Okay, hold on. Let me just show you a trick with this one, okay? Well, hold on. I need to cancel... Yes, who said that? Who just said that? No, who said they needed to cancel y? Okay, yes. I knew somebody did. Okay, I was getting ready to say, why don't we cancel a z? And I was going to see if y'all were going to catch. We can't do that. Okay, we have to cancel the same variable. Okay, so I can use... We need to use the bottom one, and then which one did y'all say you want to use? Top and bottom? Top one by 3, okay, so I'm going to do that just so I can see what I'm doing. Okay, so top one by 3.
So you, original replaced it and multiply that by 3?
Yeah. So this modified thing is only to get this part.
So we could have used what we call it.
No. I was saying for this other part because I was like, oh, we already have a 4z and a negative 4z. But that means I would be canceling z's and I need to cancel y. It doesn't matter what variable you choose to cancel. I mean, if you get ready to go and pick a really hard one, I would have told you, don't do that. But, like if you had, I mean, really, you could have started with any of them because you had a z by itself, you had a y by itself, basically, and you had an x by itself. So really, any of them could have worked in this case to start with. So the top one by 3 gives me 12x minus 3y plus 6z is equal to negative 54. Yeah. Okay, and then I need the bottom one. 3x plus 3y minus 4z is equal to 44. Okay, and on occasion you might luck out such that two variables will cancel at the same time and you're left with just like x or something. Doesn't happen super often, but don't be like scared if that happens. You can just use that and then plug it in to solve for it. Okay, so combining stuff here, what do I have? Okay, now what do I need to do? Okay, now what do I need to do here?
Are we not allowed to do that substitution now because we can do
If that's what you guys want to do and end up with some fractions, be my guest. Because you'd end up with negative 15 over 2. Yep, that's the easiest, okay? Multiply the top one by negative 2, the bottom one by 5. Okay? So negative 14x minus 10z is equal to 50. 5 times 15 is what? 75. Plus 10z is equal to negative 50. Then your signs would just be different. Why is it a no? No. She meant the signs were different. She multiplied the same number. She put a negative 5 and a positive 2. Then it's not gonna, nothing's gonna cancel. X equals 0, okay. So I'm left with here, let's see, what is this? 61x is equal to 0, so x is equal to 0. Yeah, the variable can be equal to 0, but if I had gotten here, like, if everything canceled and gave me, like 61 is equal to 0, that's a problem. But x equal to 0 is not a problem. Quickly. Okay. Now, what do I need to do with this number?
I want to plug 0 into the top one of negative 14x minus 10.
I can use this. Well, I can use that, but I would use the original just because it makes life a little easier. 7 times 0 plus 5z is equal to negative 25. So 5z is equal to negative 25. Z is equal to negative 5. Now what? Which one do you want to use? Divide 5. What?
No, what's the third one? Yeah, let's use the middle one.
Okay, the middle one probably makes the most sense because I don't have to multiply z by something. Okay, and x is 0, so the x part doesn't really matter.
Yeah, the original.
Yeah, it has to be up to one of these original, yeah. So the middle one probably makes the most sense. Okay, so 0 plus 2y plus negative 5 is equal to 11. So 2y is equal to 16. Y is equal to 8.
Oh, because you add 5. Never mind. No, that was such frustration.
Okay, how do I write my answer?
0, 8, negative 5.
0, 8, negative 5. Yeah, Brooke came up to me yesterday and goes, so how do we graph this? And I was like, you're not going to? Then I shoved a pencil through a piece of paper and showed her what it was like, and she...
You literally have to draw the eye in 3D, and then you literally have to draw like a cube, and then do...
I remember trying to draw a 3D triangle for graphing out.
You would have to draw like a perfect cube.
That's the first.
Then you have to add lines to it.
I mixed the first equation and the last equation. I did the slope wrong.
All right, are y'all ready to try one on your own?
Yeah, you bet. To be honest, I'm not ready to try one on my own. I'm so confident that I could probably do it on the board.
It's pretty easy. It's just basically adding a...
Is it kind of knowing when to do what? I still don't get it.
It's basically what we learned.
All right.
It's basically what we learned last chapter.
I learned nothing.
14 is 2x plus y minus z is equal to 9. Negative x plus 6y plus 4. Whoa, hold on. I'm looking at the wrong problem. Hello. Okay, this is 2z. 2z. Negative 17. 5x plus 7y plus z is equal to 4. Okay. All right, everybody should be working on this problem. I'm going to come around and check it for a grade. No, like if you actually did it on paper as I'm asking you to do. Okay, this is for me to see how we're doing. Okay, because I don't want to do a ton of problems tomorrow if we don't need to do a ton. I want to give you guys time to do them so you don't have to do them over your long weekend. Just work on the problem, and then she can watch the video or come talk to me or on the bus or something today. I can help her.
To be honest, I missed the first couple examples. I don't exactly.
You only missed the ones that were different, where it was just plugging in.
But it's easy one.
Yes.
That's the ones that were basically...
Just make sure you cancel the same variable both times.
So much room for error there. Like, you can mess up, like, one thing, any of these, and you're like, done. I didn't even say that.
No, there's not a fraction. Check your sign, because I had a fraction and realized it was wrong because my sign. Then your sign's wrong. Because that was my problem. And then... Don't talk about it.
Do not say it.
That's just not right. Like, that just can't be right. How can you
How did you get that? Yeah, one of them would be negative, because you're going to have to cancel one of them. Okay, we'll wait for everybody else. You love this stuff?
I just did it. Like, I think I did it right. Well, I had to start it over. I did.
Okay. Yeah. 3z. Negative 25. That's right. Do you have negative... Wait. This would have been positive 37, positive 11, and negative 81. Because 30y plus 7y is 37y. I have it right here. Negative 85 plus 4 is negative 81. So you have it positive over here, you just have it written positive over here. And you need to multiply these two equations by something. You're going to have to multiply them both by something to get it. Yeah, they're huge numbers. But they cancel nicely. Well, you have 11 and 3, so I would multiply this one by 11 and this one by 3. One of them needs to be negative. You can decide which one.
Very, very confused. I already started it like 4 times. Okay. Did I even start that right? This is what
Yes, but this is, you multiplied this one, you should have multiplied this one by a positive 2. So that should be positive.
Okay.
And then, yeah.
Okay. And then after I get that, then what? This is where I'm confused. This is where I get lost. Because I know I have to pick from these, right? I don't need to worry about this one.
Yeah, you can ignore that one for the moment, other than you know that you need to cancel x because that's what you do, that's what you chose to cancel here.
Yeah. So then I've already done x, so I can't do it again.
Well, no, you need to do x again because you need to have 2 equations that don't have an x in them.
Okay, so like I can multiply this by 5.
Yeah, so like I would use, yeah, like the bottom one and this one. Or sorry, the middle one and the bottom one. You're good, you can leave it. So you chose different equations.
I originally did these 2, but I did x.
Yeah, that's what I did. So what did you end up doing? Z?
Yeah, I ended up doing z.
Might be easier, honestly. your numbers look easier.
They even out, like, because I have my y, my negative y, and then I'm at negative 8x. Or maybe it is a spread. No.
So those 2 canceled. So wait, which one did you use to get this? Top and bottom?
These 2.
Wait, so this one came from these 2 middle ones?
Yeah, the 2 on the bottom.
And these came from the top 2, okay.
No. Because I have a lot of money.
So this would give you negative 11, negative 8y, negative 25, okay. So those 2 equations are fine. These conveniently cancel, so that gives you negative 8 and...
Yeah, I thought I was doing it right. I was like, on a roll. I was like, yes, I got it.
Oh wait, this is 18 minus 17, so that would be positive 1, not negative 1. So then that'll do it.
You're right. I think I'm off by 1, but can you right?
Your y value. Where did you solve for y? Right here?
Yes.
I think I'm right.
So 3 plus... My y's over here. What did you cancel initially?
Y.
So you got rid of y up here in this step? Okay.
I canceled out a different one, and I got a completely different answer, but it fits in one of the problems.
I'm really close.
I did the second one instead.
Yeah, you're right. I'm off by 1. Okay, so this is what I did. I used simpler numbers, I think. None of mine went over like.
Tabitha canceled z and it worked like way better. I canceled x.
I canceled Z, but I got this still.
I canceled a lot.
I don't know how.
You should still get the same answer if you cancel z.
So I canceled Z. Mine's really hard to follow. So I went to here. I don't know. But I got the right answer.
Okay, we'll go over it tomorrow. Don't worry.
So I did this, and I got 7.
I got the answer.
So you got 3. This is negative, and then when that becomes negative, it should fix that.
Negative.
This y should have been negative. Because you had negative 8y here, or you should have negative 8y. So even though that's positive 8, dividing by negative 8 will give you negative 1.
Thanks.
And then that'll fix your bottom, that'll fix your z.
Thanks. I'm sorry.
No, you're good. It's a lot of like little things like that can like throw your answer off. That's why I say I'm not like, as long as you show all the steps so I can see where it went wrong, I'm pretty generous with like partial credit on these ones.